Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous video tutorial, we continued with our exploration of the LandSat data series. Specifically, we focusing on LandSat 5, 7, 8, and 9. In our previous video tutorial, we displayed each of those LandSat medium images for the specified time period. And we compared between the four medium images to understand possible land use changes, urban changes, etc., etc. What we agreed upon is that given the size of this region of interest, we have to zoom into specific locations or specific areas in our region of interest to get a better understanding or to better visualize the possible land cover changes, etc., etc. So viewing it that from this far seems a little bit pointless, therefore we need to zoom in a little bit. And then we also started playing with the visualization parameters within the 432 true color band option. Remember, 432 for Landsat 8 and 9, 321 for Landsat 5 and 7. That's the true color bands. Okay, so in our case, we are at the moment only playing around or using the Landsat 8 time series, but remember, you can do exactly the same for the other three Landsat data sets as well. I'm just using Landsat 8 for simplicity. Doesn't matter. Okay, so we will continue with this, but where we ended off in our previous video tutorial to say, okay, we've only in that video tutorial worked with the true color bands, meaning 432. Let's play around with those band combinations and see how that visualizes the region of interest. And maybe, there's specific features that will be highlighted or diminished depending on the band combination. Because remember, what we want to do is to identify features of interest within this region of interest, and different band combinations might highlight or diminish certain features. So as I said, this is our true color band image, which is basically the 432 selection in our Landsat 8. Remember, this is a medium image for the duration, and band set 432 is our what we call true color or natural color that we present. Okay. So remember, in the previous video tutorial, we played around with all these stretching options. And remember, the stretching is just playing around with the minimum and maximum, the range in values within each pixel. Okay. So what we're going to do now is to play around with our bands. Play around with the bands. As I said, 432, the two color band, is most probably the most widely used band. The second most widely used band, I would argue, is the false color band. So this would be then band 5, 4, and 3. So this is called a false color band. So basically what will happen is vegetation where it is now, vegetation would be green or blackish colors or brown colors, it will just make that red. Now remember what band 4, 5, 4, and 3 is within the band sets. Okay, so to determine what band 5, 4, and 3 is, let's go back into our Landsat landing page. Remember, we're working with surface reflectance, tier 1. And there's our bands. So in our case, our false color will be band 5. In our case, band 5 is near infrared. Okay, so band 5 is near infrared. Then band 4 is red, and then band 3 is green. Okay, so in this case, it's infrared, red, and green. Okay, so that is the band combination here. It's infrared, red, and green. Okay, so um, vegetation would absorb red and reflect green. Okay, so this is basically the argument in this case, is that why we're using so much red is because of the reflectance of vegetation. Okay, so let's apply and see what happens. Okay, so again, make sure that you understand what band 5, 4, and 3 is, and to get the understanding, you basically go to the landing page and you will get its description. There's the bands that we're now using: 5, 4, and 3, which is infrared, red, and green. Okay, we press apply, and the image should now um, be reworked to reflect these three bands in what we call a infrared false color. So you can see there um, the red's starting to appear. So um, yeah, given the region of interest, the size of it, the images will take a bit of time. And if your region of interest is a bit smaller, obviously it will be much faster and much quicker. But you can see here, close to the river, next to the river, where it's typically greenish, it's dark reds. Areas where there's very little vegetation stays as is. Um, you can see here's quite a lot of farmland, specifically grapes and wheat, which is, greenish stuff. It appears quite red. Okay, so you can see that areas with high vegetation um, appears much more red than in the previous true color, where it's more green or dark blackish color. In this case, it's more red. Whereas your sand areas stay sand simply because there's no vegetation. So that is one band combination that we can present, and this is typically to highlight um, vegetation areas within our region of interest. Another false color that we can apply is the band combination 7, 6, and 4. Okay, so that's another band combination. Again, play around with these combinations. Um, so let's have a look. What is band 7? Band 7 is shortwave. So this is a shortwave band. Band 6 we already said is the uh, 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 band 7 and 6. Band 7 is a shortwave band. Band 6 is also a shortwave band. So these are two shortwave bands. And then we have band 4, which is red. So in this case, it's shortwave in, and a red band. Let's press apply and see what that image looks like. I said, remember, familiarize yourself with the bands and the um, the scales of these bands, the wavelength of these bands. You'll see, although we've got two shortwave bands, 6 and 7, the wavelengths that they um, record the surface reflectance are quite different. Okay, so in this case, you can see um, the vegetation is highlighted much more in a green color than compared to the red color of the previous ones. Again, if you vaguely remember, there's that white sandy areas that in one of our true color um, stretching images appeared very white. Um, um, there's no vegetation, so in our previous false color, it just looked like normal, but you can see vegetation is presented in a much more green or natural color than in the previous images. So that is also a false color. Let's look at another band combination. Let's look, for example, at band combination 6, uh, 5, and 4. So in this case, 6, let's have a look and see while I'm pressing apply. 6 is a short wave. So this is a short wave, infrared, and a red. So short wave, infrared, and a red combination. Let's see what that combination looked like. And there it's starting um, to display itself. Again, you can see the green areas are highlighted here around the river. You can still see the sandy patches here highlighted in white. Sort of um, light vegetation, mostly little stones and rocks areas are highlighted in brown. The mountains and then the vegetation on top of the mountains, and this is agricultural land. So you can see agricultural areas in this case is a little bit more like almost like a yellowish green color. Natural high vegetation is green. Um, Shrubs area is located in brown. And then sandy areas are white and this color brown. Um, just again, just remember that the surface reflectance of urban areas or man-made structures and sand are very, very similar. So it is not always possible to distinguish between the two. You can see these areas here, those are dams or big rivers. You can see there's one there, there's one there, there's one there, and then obviously there's a river. So it displays the rivers in a sort of a bluish color. So this is also quite neat to, and it again identifies certain features. Let's have a look at combination. I'm just picking random combinations here. 7, 5, 4. So this is not the first short wave, um, not the first short wave, but the second short wave. And therefore, I don't think the image will look um, quite different to the previous image. And again, yeah, it doesn't look that different. So it doesn't necessarily mean that you have to make huge changes, in the bands. You can use subtle changes in the band 5 to 4 or 4 to 3 or something to that. Doesn't have to be from 7 to 1 or 1 to 7, etc. And here you can see again how the vegetation, whether it is natural vegetation or agriculture, is just highlighted. And you can again see the sandy patches here, etc. Okay, so that's just a nice um, subtle difference using the first infrared, which is 6, and the second infrared, which is 7. Okay, so let's have a combination. Let's say 6, 5, and 2. 6, 5, and 2. Let's have a look and see what that is. 6 is shortwave, 5 is near infrared, and then we have 2, which is blue. Okay, so this is short infrared, near infrared, and a blue color. Okay, blue, remember, blue is bands at 2, 6, and 5, shortwave, and near infrared. Okay, let's have a look and see what that comes. Oh, this looks quite different to the previous one. Um, this displays the soil in a much more yellowish color than in where we used 4. So the red, remember, red 4 is red. So this is the blue, so it becomes much more yellow. Whereas we use the red, it goes much more green. Um, so you're starting to get an understanding of the colors, and remember it's reflectives. Okay, so you're picking up how much. So if it's red, you're picking up how much of the red are reflected back. So things that will absorb red obviously will appear much less red, and vice versa. Okay, so that's interesting combination as well, 652, which is a blue combination with the infrared and the shortwave. Okay, so let's have a look at another one. Let's look at 7, which is second infrared. We're looking at 6, which is um, the second, second shortwave. The second shortwave, yeah, 762. Let's have a look at that. So that is 7. Let me first run it while it's. So that 7 is the second shortwave, the first shortwave, and blue. Okay, we stick with LandSat band 2, which is blue. You see that's become more a green, yellowish type of color compared to when we use the 7.6, like the 6.5 combination. Okay, so that's another combination which gives you a different visualization of our region of interest. And again, you're using this just to identify features or to see in which combination does what features stand out or is much more prominent. Um, so again, yeah, so let's have a look at 5, 6, 4, 5, 6, and 4. So this is now in different formats. Um, the red band in our case is 5, the green band is 6, and the blue band is 4. Remember, that's what RGB stands for. So the first band is also always the red band. So in our case, the red band is band 5, which is the near infrared. Our green band is band 6, which is our short wave, and band 4, which is our red band, is in the blue band. Okay, so let's press apply and see what this band combination looks like. Um, and I said, you can really, you know, play with these bands combinations to extract the features that you are interested in. Okay, so that's um, again, so the shortwave bands seemingly produce much more greenish, natural color type images um, of our region of interest. So that is 5, 6, and 4. You get the idea that it's again, and then let's have a look at 5. Um, let's have a look at 5, 7, 1. We haven't used 1 before, so let's have a look at 1. So in this case, it's 5, which is our near infrared. 7, which is our short wave, and then 1, which is our ultra blue coastal. So that will give you an, I assume, indication of water on water bodies, simply because that band is included. And yeah, you can see the rivers are um, visualized in a sort of brown, reddish color, but it's quite prominent. So this is an indication of water bodies. You can see all the water bodies within the area. So that's a good combination to use. So we've basically done 1, 2, 3, 4, what's about 8 or 9 images that we've created using different band combinations. Now, the combination is important, but also how the structure of the combination is important. So let's quickly go back to our initial true color, which is 4, 3, and 2. Let's apply. So that's our initial true color. So in this case, in our red band, we have band 4, which is red. You can see that. So the red is in the red. The green is band B at 3. You see, green is in green. So you see there? So red, green, and blue, red, green, and blue. So the band combinations and the band structure is exactly the same, and that's why it's giving us the true color. So, okay, remember, then band B2, band 2 should be blue. Let's have a look and see. Band 2 is blue. So that's the true color combination in the true color structure, which is red, green and blue. Now let's say we swap these colors around. So I'm going to make blue of the green color in the red band. I'm going to keep the green color in the green band, and then I'm going to make the red color in the blue band. Okay, so I move the blue color in the red band. I'm keeping the green color in the green band, and I'm changing the blue, including the red color in the blue band. So it's the same band combination, the 2, 3, 4, 4, 3, 2. I've just structured it in a different way. So let's have a look and see what that visualization looks like. And you can see it's very, very different. Now it becomes much more blue simply because we have blue in our red column. Okay, so what the bands are that we're displaying is important, but also the structure that we enter our bands are just as important. So you can see in this case we swapped the red and the blue bands. We swapped and we kept the green bands. You can see the image looks very, very different. Then let's, for example, let's swap the green band and the blue band. So we're going to make the red band now in the green band, and we're going to make the green band in the blue place. Okay, so let's have a look and see what that looks like. You see now it becomes very, very green. So there is 3 different visualizations of the region of interest using the same bands but in different structure. Okay, so the band combination is the same. It's just the structure of the band combination is different. Okay, so let's look, for example, at 7, 5, and a 2. See if we've done that one. I'm not sure if we've done this combination. So I'm putting my second short wave in my red band. I'm putting my red, my infrared. I'm putting my green, and I'm putting my blue in my green band. Okay, so this is what that looks like. Okay, so let's swap this one around. So I'm going to make the 7, I'm going to change into a 2. Let's keep the 5 same, and I make this the 7. Let's see what that you can that visualization parameters present or give us. Okay, so as I said, we basically are just playing with our band combinations and the structure of our band combinations, and the idea is to develop images that present different features or diminish certain features so that you can identify features much more clearly within the region of interest. So there's a different combination of presenting LandSat 8 or in terms of band 2, 5, and 7. So remember, the starting place is always your natural colors or your natural image, which is 5, 3, and 2. That's always your natural color. That's also always your starting point. And then from this starting point, you start changing the bands and the structure, band combinations and structures of the combinations to see what the resulting images looks like. If you're happy with it, you can basically keep it, and then you can go into your script. Let's say this is our LandSat 8 script, and you simply just change the band combinations within your script. Remember, always 3 bands. You cannot do more than 3, cannot do less than 3, except if you go for the 1 band. Otherwise, you go for the 3 bands. Okay. So there's our different combinations. So this gives us room and scope to really explore the different visualization parameters within the LandSat data sets. Remember, we're still working with a medium image. We haven't even worked with the mean or the sum image. So interesting. Let's look at our true color and our median, and let's change that to mean. Okay, as an example, LandSat 8 mean, and then let's see what that true color image then looks like. I'm gonna just unselect my other images so that this image loads a little bit faster. Remember, all I've done is now I've changed the statistic so that it's not the mean of image of all of this image collection, the median, but the mean image. Okay, so just bear with the engine. It will take a bit of time. Let me pause and we'll come back as soon as it is available. As a matter of interest, as I said, up to now we work with the median image, LandSat, where is it now? LandSat 8 image. As a matter of interest, I've also just created a LandSat mean image and a LandSat sum image. And I've also then just displayed, just to see the differences or similarities between using the median function, the mean function, and the sum function. So there is the median function image that we've used so far. If we then select the mean function, you'll see that the mean function is much more, much more lighter, almost a transparent light. But yeah, so if we select between the two, you can see there's the median image and there's the mean image, reinforcing the use of the median statistics as the important one. Then if we use the sum function, you can see the sum is totally just one big white color. So there is the sum image, there is the mean image, and there is the median image. So again, confirming the median image. Now, what is interesting, we can actually generate the statistics as what we did in our previous video tutorials with the nighttime lights. We can use the inspector. So let's focus on this. But well, we choose an ad hoc area. Let's say one of these sandy patches. Okay, so let's use the inspector there. Now it's going to generate the values, the band values for that specific location. Okay, so in this case, let's go and have a look and see the median, LandSat median image. There's our, if we export that value, there is the median LandSat 9 images. Let's go and have a look and see the mean images. There's our mean. Let's export that as well. So let's look at, it's very, very small. Okay, so let's use band. Unfortunately, these values, yeah, obstruct the size because these are much, much smaller. So it's a little bit difficult to see. But let's have a look at, let's say band 10 is 300.8 in our median. Band 10 is 301 in our mean image. So you can see there is differences. Let's take this one. We have to actually, so 21 and 24. So you can see there's differences in the absolute sizes of the bands in terms of median and mean, which is um, not surprising. And then obviously the sum is way, way, way much higher in the thousands. With these, yeah, in almost, well, let's see, yeah, well, in the millions, not in the thousands, in the millions, where these ones are in the thousands. So you can see there are some fundamental differences, but the combinations of the bands still stays exactly the same. So as I said, for our case or example, using the median um, is the way to go rather than using the mean or the sum. The mean and the sum in all cases is substandard compared to the median. Okay, so that is this for our video tutorial on the band combinations and the structure of the band combinations and the different displays, visualization displays that we can generate from using different combinations and different structures. Thank you. Yeah, I think that's it for this tutorial video. Thanks for for staying tuned, and thanks for following these tutorials, these videos. And welcome again, and thanks for joining me on this wonderful journey of remote sensing. We have just started, so there's still lots to explore, lots of interesting things that we're going to explore. So stay tuned, and I'll see you on the other side.